Hello, I'm Tyler Whitson, and for my research paper, I looked into the effectiveness of drilled shafts. To begin with, I'll go into what drilled shafts are. Drilled shafts are a deep foundation that has a small footprint. They are drilled out with an auger and um, a big crane-looking drill, and then they have concrete poured into them with reinforcement with a reinforcement cage to create reinforcing concrete. Um, there on the left, there is a demonstration of how the resistance to bearing is performed on the drilled shaft. A majority of the bearing is performed by the end of the drilled shaft, which is usually grounded in rock or very stiff clay. And then there's also side friction that helps with the um, bearing resistance. On the right, there is a demonstration of how a drilled shaft is made. First, there is a drill that goes down and drills to the appropriate depth um, called out by the plans from the geotechnical design. And then there is usually a casing put on, either a temporary or permanent casing, and then there is a rebar cage that gets dropped into the hole, and then there is concrete that is poured to create the drilled shaft. Now on to my analysis. For my analysis, I focused on a drilled shaft that is set in sand and or a layer of sand and then a layer of clay that becomes stiff enough for the drilled shaft to sit on the clay. So to compute the total bearing resistance, I followed the drilled shaft manual provided by FHWA. And to begin with, you find the resistance due to each of the frictions. Obviously, your sand friction is going to be different than your clay friction. And then you find the bearing resistance or your resistance from the bottom of the shaft. And you can see the formulas labeled there. There is just the base formula, and then there's a plugin of how to calculate out all of um, the individual resistances. Paper, I was focusing on showing the effectiveness of the drilled shaft, not just calculating out what a drilled shaft would perform, or the bearing the drilled shaft would provide in a set um, soil selection. So to prove out its effectiveness, I did a case study of a bridge that I worked on in work for a county, Reno County in Kansas. Um, that county requested that there be piling instead of drilled shafts, so the project had piling. It had quite a lot of piling. Reno County is known for being in sand dunes, and below the sand dunes there is clay for quite a significant depth. Because of this, it was extremely similar to the calculations that I performed on the previous slide. Um, and so I looked into this and I got the individual piling bearing resistance for two different sets of piling for HP 1042s and HP 1253s. Here are the results of the previous two slides. First, the one drilled shaft provided, according to my calculations, 1058 kips of resistance to bearing, and then the two piling that I had mentioned, it took 12 piling to get or to equal an equivalence of what that one drilled shaft provided, or 11 HP 53 piling to equal an equivalence of what that one drilled shaft provided. This just shows the effectiveness of that one drilled shaft and how much smaller of a footprint that the foundation would have. Finally, I looked at two related studies. The first was shaft resistance of drilled shafts in clay, and the second was the robust geotechnical design of drilled shafts in sand. These two papers were very interesting to look at, and they just shedded more light, and they went a lot more in depth into the uniqueness of both clay and sand. Specifically for the clay, it went into the shear strength of the clay and how that is really good for drill shafts. Here are my references. I hope you all have a good day.